22 miles. That is the number that should stop every single person watching this video in their tracks right now. 22 miles is the distance between the forecast closest point of approach of the eyewall of Typhoon Sinlaku and the northern runway threshold of Andersen Air Force Base on Guam, one of the largest American military installations in the Pacific Ocean, on an island of 153,000 people, and a storm that is right now, at this hour, packing 100-mile-per-hour sustained winds, spinning up toward 145-mile-per-hour sustained winds, and accelerating northwest at 5 miles per hour directly at the Mariana Islands. 22 miles. That is the distance you might walk in a day. That is the gap between the center of a Category 4 typhoon and the coastline of American soil. And it is getting smaller with every hour that passes, but the 22 miles is not even the real story. The real story is what is happening to this storm right now. In the hours before dawn on April 12, 2026, as the people of Guam board their windows and fill their water containers and try to decide whether their house is strong enough to shelter in place, or whether they need to move to one of the emergency shelters the Guam Department of Education is opening this morning. The real story is what rapid intensification actually looks like from inside the physics of a tropical cyclone. What it means when the atmosphere and the ocean below it are so perfectly aligned, so completely lacking in any brake mechanism, so loaded with thermal energy that a storm can go from a tropical storm with 63-mile-per-hour winds to a roaring Category 4 typhoon with 145-mile-per-hour sustained winds in 4 days. 4 days. That is the timeline of Sinlaku's life so far, from a disorganized low-pressure disturbance near the island of Chuuk on April 8th to the Category 2 equivalent system churning northwest with gusts of 120 miles per hour at its center right now. And it is not done. The system is still building. The fuel beneath it has not run out. The wind shear above it has not increased. Every instrument watching this storm is reading the same message. The worst is still coming. Let us be precise about what the data shows right now, because in a situation like this, precision is not a clinical exercise. It is the difference between life and the failure to prepare. As of 10 p.m. Saturday, April 11th, Guam time, Typhoon Sinlaku was located approximately 535 miles southeast of Naval Base Guam, moving northwest at 5 miles per hour. Maximum sustained winds at center, 100 miles per hour. Gusts, 120 miles per hour. The Joint Typhoon Warning Center, which is the United States Navy and Air Force task force at Pearl Harbor that provides official tropical cyclone guidance for the entire Western Pacific, has its latest forecast track placing Sinlaku's closest point of approach between the islands of Guam and Roa. The track consensus mean from all available models has now converged to a position just northwest of Guam, meaning the center of the storm may pass closer to Guam's northern coast than previously anticipated. The peak intensity forecast, 145-mile-per-hour sustained winds with gusts to 175 miles per hour late Monday evening just before closest point of approach, 18 miles southwest of Roa, 22 miles northeast of Andersen Air Force Base. Those are not the same as a direct landfall, but they are close enough that the question of whether the eyewall passes over Guam's northern tip is one of margin, not certainty. Brandon Aidlet, the chief meteorologist at the National Weather Service Guam office, the man whose office sits in the direct path of this storm, whose radar dome was destroyed by Typhoon Mawar in 2023 and who has rebuilt and is watching again, went on live television and said these words: "The latest forecast track out of jtwc reflects a Category 4 typhoon moving through the Marianas right near Guam." He said it plainly. He did not hedge it with model uncertainty language or probability caveats. He used the word alarming when describing the early jtwc advisories on this system. A National Weather Service chief meteorologist calling a track alarming is not routine communication. That word carries weight. It means the man who reads forecast data every day for a living looked at what the instruments were showing, and used the same word a person uses when they see something they did not expect to see, and know others need to hear it immediately. Now translate what 145 mile per hour sustained winds means at human scale. Wind speed does not increase in a linear relationship with destructive power. The destructive force of wind increases with the cube of its velocity, meaning that a doubling of wind speed produces 8 times the destructive force. The difference between 74 mile per hour typhoon force winds and 145 mile per hour Category 4 winds is not a factor of 2 in terms of damage. It is a factor of 8. At 74 miles per hour, winds peel roofing, down trees, collapse poorly constructed walls, shatter windows, and turn loose objects into projectiles. At 145 miles per hour, winds do all of that and then continue. They strip the bark from standing trees. They demolish roofing systems that passed building codes. They strip the steel reinforcement from concrete structures not designed to those specifications. They generate storm surge, a dome of ocean water pushed ahead of the storm that floods low-lying coastal areas with seawater carrying debris at the same speed as the wind. They send small boats airborne. They take apart anything that was not engineered specifically to survive them. During Typhoon Mawar in 2023, which struck Guam at 140 miles per hour, 5 miles per hour less than Sinlaku's current peak forecast, 98% of the island lost power. The NWS radar dome was destroyed. The airport's wind measurement instruments were demolished after recording a 108 mile per hour gust before they failed. Dry docks at the Opera Harbor were partially submerged. Resorts along Tumen Bay, the economic heart of Guam's tourism industry, were reduced to standing frames with contents exposed. Mawar left a jungle, in a meteorologist's own words broadcast live, looking like toothpicks. Sinlaku is forecast to be 5 miles per hour stronger at landfall than Mawar was, and the models show it possibly strengthening further. Here is where this story becomes genuinely alarming in a way that pure wind speed numbers do not fully capture. The slow movement matters as much as the intensity. When Sinlaku arrives, it will arrive slowly. The storm has been moving at 5 miles per hour. That is a fast walking pace. It is not racing through. A tropical cyclone moving at 5 miles per hour does not deliver a single blow and pass. It sits. It parks over a location and continues to pour rainfall, sustain its wind field, and drive its storm surge for hours. Brandon Aidlet told the public explicitly, this event will be prolonged. Impacts will last from Monday midday through Wednesday afternoon or beyond. He said, do not be surprised, it is going to be long going. Think about what that means concretely. 15 to 20 inches of rain are forecast for Guam between Sunday night and Wednesday. Chuk Lagoon, the first significant island community to be struck by this system as it tracked northwest, was receiving 70-mile-per-hour winds at center with large trees coming down, shoreline erosion and flooding of the western-facing island communities inside the lagoon. Chuk is forecast to experience another 24 to 36 hours of dangerous conditions before the storm moves far enough away to allow conditions to improve. Chuk is the preview. It is the field observation of what Sinlaku does to a populated island chain before the instrument readings and the modeled forecasts have to prove themselves. And what it does, according to reports from the ground as of this morning, is exactly what the models said it would do: sustain structural damage, downed vegetation, flooding, and conditions that make movement and rescue difficult. Guam is next. The Mariana Islands are next. And at 145 miles per hour, the version that arrives at Guam will be far more powerful than the version that is currently grinding through Chuk. The cloud top temperatures inside Sinlaku's central convective core have reached minus 97 degrees Celsius. That number requires a moment. Minus 97 degrees Celsius is not a temperature that occurs in the lower atmosphere under normal conditions. It is a temperature found at the very top of the troposphere, at the boundary of the stratosphere, where the tops of the most explosive thunderstorm towers punch through the tropopause and overshoot into air so cold that ice crystals fall back as cirrus plumes. When a tropical cyclone generates cloud top temperatures in that range, it means the convective towers inside the eyewall are reaching altitudes of 15 to 18 kilometers, reaching up into a layer of the atmosphere where pressures are less than a tenth of what they are at sea level, where the air is so thin that jet aircraft require pressurized cabins. Those convective towers are the engine cylinders of the typhoon. They are the vertical pipes through which warm, moist air ascends from the ocean surface, releases its heat as it rises, and drives the rotation that powers the entire system. When those towers are reaching the stratosphere, the engine is running at full capacity. The system is not struggling to organize, it is organized. It is performing at the upper boundary of what the atmosphere can physically produce. And the ocean beneath this storm is the reason that is possible. The Western Pacific, in the corridor that Sinlaku is now traversing as it tracks northwest toward the Marianas, has been running anomalously warm. Not just at the surface, deep warm water, the kind that does not get mixed to the surface and cooled when a powerful tropical cyclone churns it, the kind that sustains intensification even as the storm draws enormous amounts of heat out of the uppermost layer. When a strong typhoon passes over a shallow warm layer, it can cause upwelling of cooler water from below and effectively cool its own fuel source, limiting intensification. The atmospheric and oceanic regime beneath Sinlaku has been described by jtwc forecasters as highly favorable throughout the forecast period. That phrase, in the context of a system already at Category 2 equivalent strength and heading toward populated land, is the meteorological equivalent of saying the car has a full tank and the road is clear and the speed limit signs have all been taken down. The historical record confirms that what is unfolding is extraordinary. To find a typhoon of Category 3 equivalent or stronger affecting the Mariana Islands in the month of April, you must go back to 1989, to Super Typhoon Andy, 37 years ago. The typhoon season in the Western Pacific officially spans May through October. April storms occur, but April storms of major intensity near the Marianas are historical exceptions, not the baseline. The fact that Sinlaku has reached Category 2 strength, right now, this morning on April 12th, and is forecast to reach Category 4 strength at its closest approach in under 36 hours, is not routine. It is not part of the normal expectation for what April produces in this basin. And it did not happen in isolation. The 2026 typhoon season began in January with Tropical Storm Nokayan, the earliest season start since 2019. The basin has been active before it was supposed to be active. The water was warm before it was supposed to be warm. The atmospheric conditions that favor tropical cyclone development assembled ahead of schedule, and Sinlaku is the manifestation of that early readiness, a storm that arrived 3 months before the height of the season and has nevertheless found all the ingredients it needs to become one of the most powerful storms to affect American territory in the Pacific, since U2 struck Saipan and Tinian in 2018 with sustained winds of 180 miles per hour and reduced entire neighborhoods to bare foundations. The people of Saipan, in the Commonwealth of the Northern Mariana Islands, remember U2. They remember what 180 mile per hour winds sound like when they are not outside with them but inside a concrete building in the dark, when the walls flex and the roof membrane peels and the steel shutters bow inward. They remember what the island looked like on the other side of that storm. A landscape stripped of vegetation, roads buried under debris, the power grid down for months, water service interrupted for weeks, and a federal disaster recovery process that cost over $1 billion and required years of sustained effort. Saipan's population of 48,000 is now under Typhoon Condition III, declared by Governor David Apatang, meaning typhoon force winds are considered possible within 48 hours. Rota, Tinian, and Saipan are all in the warning corridor, and for Rota, the small island with a population of roughly 1,600 people, sitting 18 miles from Sinlaku's forecast closest point of approach, the potential for eyewall passage is real and the margin for error is measured in nautical miles, not tens of nautical miles. Think about Rota for a moment. 1,800 people on an island roughly 9 miles long. Rota is known for its quiet, its coral reefs, its village of Song Song, which sits in a bay on the island's southwestern coast in exactly the direction from which Sinlaku is forecast to approach. The villagers of Song Song are not strangers to typhoons. No one in the Marianas is a stranger to typhoons. But 18 miles of separation from the eyewall of a Category 4 system is not a comfortable margin. The wind radii extend well beyond the eye. Typhoon force winds, 74 miles per hour and above, can extend 50 to 80 miles from the center of a major typhoon. At 18 miles from the eyewall, Rota is not just in the wind field. It may be close enough to receive the most intense portion of the wind field on the eyewall's outer edge. The National Weather Service Guam forecast anticipates 15 to 20 inches of rainfall for Guam and Rota combined. Rota's steep topography, the island rises sharply from the coast, creates the same kind of flash flood conditions that make steep-sided Pacific islands so vulnerable to intense rainfall. Water collects and accelerates down narrow drainages with little warning, and the slopes, already soaked, lose cohesion and send mudslides into roads and structures below. Now add the second connected system, because this storm did not grow in a vacuum, and it will not end in a vacuum. There is an active debate in the tropical meteorology community about the role of deep ocean heat content, as distinct from sea surface temperature, in fueling rapid intensification events of the kind Sinlaku is now demonstrating. The traditional model of tropical cyclone intensification focuses on sea surface temperature. A storm needs water above 26 to 27 degrees Celsius to sustain itself. That threshold remains accurate. But what the observational record of the past decade has shown, repeatedly, is that the most extreme rapid intensification events, the ones that take storms from Category 1 to Category 5 in 24 to 36 hours, the ones that produce the most shocking jumps in destructive potential just before landfall, are consistently occurring in regions where not just the surface but the layer of warm water extending down 100 to 150 meters is anomalously warm. When that deep warm layer exists, a rapidly moving storm cannot cool its own fuel source by churning up cold water from below. And a slowly moving storm, one like Sinlaku crawling northwest at 5 miles per hour, has even more time to draw heat from that deep reservoir because it spends more time over any given patch of ocean. Slow movement plus deep warm water plus low wind shear is a combination that atmospheric scientists have identified in the case histories of some of the most destructively intense typhoons ever recorded. Sinlaku is not just checking one of those boxes, it is checking all three simultaneously. The second connection is what happens after this storm. Sinlaku's projected Post-Mariana's track, after it recurves northward and eventually northeastward, carries it toward the volcano islands, including Iwo Jima, Japan's southernmost island chain, and then potentially toward the Japanese mainland if the recurvature is late and shallow. The track forecast beyond 72 hours carries low confidence at this stage, meaning the Post-Mariana's track is still uncertain. But the same warm western Pacific that is fueling Sinlaku's rapid intensification now will continue to provide energy to a weakening but still active system as it curves northward. The Japan Meteorological Agency will be watching, the jtwc will be watching, and anyone living in the potential recurvature corridor, from the volcano islands northward toward the Ryukyu chain and the Japanese mainland, We'll have a few days to watch Sinlaku's behavior near Guam before making their own calculations about what comes next. What comes next, based on the current models, is a system that weakens modestly as wind shear increases north of the Marianas, but that is still a significant tropical cyclone as it moves through the Philippine Sea and turns toward higher latitudes. For now, the urgent focus belongs entirely to the Mariana Islands and the 36-hour window that closes Monday evening. The decision timeline for the people of Guam is already deeply compressed. Brandon Aidlet told the public that tropical storm force winds, 39 miles per hour, the threshold at which outdoor movement becomes dangerous and driving through standing water becomes potentially fatal, are expected to arrive Monday morning to midday. That means the window for last-minute preparation, for moving to shelters, for securing property, for getting out of flood-prone areas, closes by Sunday evening at the absolute latest. After that, the outer bands begin. After that, the rain starts accumulating on already saturated ground. After that, the roads that are not yet flooded begin to flood. The government of Guam's emergency response apparatus has understood this from the beginning of the week. State of emergency declared, emergency shelters being prepared at school facilities, pharmacy at the Behavioral Health Center opening Sunday morning for last-minute medication pickup, trash collection suspended through Tuesday, all government facilities shuttered. The system is not pretending this is a routine event. The system is behaving as if this is what it actually is, a major typhoon tracking to within 22 miles of the northernmost runway of the largest U.S. Air Force Base in the Pacific on a Sunday morning, with impact expected before the following Tuesday morning is over. Joint Region Marianas set Tropical Cyclone Condition of Readiness 3 at 10 p.m. on April 11th for all military installations. TCCOR 3 means damaging winds are expected within 48 hours. Joint Task Force Micronesia, in the language of the official statement, is fully postured to respond at a moment's notice. The U.S. Coast Guard sector at Santa Rita is coordinating with the National Weather Service and the Office of Civil Defense. 3 U.S. military installations: Andersen Air Force Base in the north, Naval Base Guam at Opera Harbor in the west, and the Coast Guard sector, are within the impact corridor of a storm that will at closest approach be 22 miles from Andersen's perimeter. No military planner looks at that number and treats it as comfortable distance. Aircraft have been repositioned or will be. Harbor assets have been secured or will be. The specific intersection of a major typhoon with a major military strategic installation, in a region where U.S. strategic posture depends on the sustained operational readiness of forces stationed in the Pacific, is not just an emergency management situation. It is a readiness situation whose implications extend beyond the immediate storm timeline. The wave height data has been public since yesterday. 9.1 meters, measured at the storm's current position, representing the sea state generated by a system that has not yet reached its peak intensity. In the 36 hours between now and Sinlaku's closest point of approach to Guam, the wind field will expand, the wave heights will grow, and the coastal inundation that will accompany the storm's passage will be driven not just by storm surge, the meteorological tide dome pushed ahead of the cyclone, but by the sustained wave action of a mature major typhoon arriving on a coastline that faces the direction of the storm's approach. Guam's western coastline, where Tumen Bay and Opera Harbor are located, faces the Philippine Sea and the approach direction of the storm. Guam's eastern coastline faces the Pacific and the fetch of the storm's outer wind field. There is no sheltered coast from a storm of this size and proximity. The expansive wind field covers the entire 30-mile island simultaneously. The outer 34-knot wind radii of this storm will encompass the entire Mariana Islands chain. There is a specific quality to the hours before a major typhoon makes its closest approach that anyone who has been through one will tell you about. It is not the wind that arrives first, it is a quality of the light. The sky turns a particular color in the outer spiral bands, a greenish gray that looks wrong in a way that cannot be articulated but can be felt immediately. Then the first gusts arrive, inconsistent at first, then longer, then sustained. The rain begins horizontal, then the trees begin to move in ways that do not look like trees moving in wind. They begin to move as if the air itself has become a liquid. Then visibility drops to meters, then the sound. People who have been through major typhoons in the Marianas describe the sound as the thing they least expected and cannot forget. Not a howling, not a roar, but a sustained, unvarying, total spectrum noise that is less a sound than a physical pressure that enters through every surface of every structure simultaneously. That sound will arrive on Guam Monday evening. It will persist through Tuesday morning. It will be 145 miles per hour at its source, 22 miles away, with gusts to 175 miles per hour. The question that no forecast model can answer, the one that meteorologists are careful to leave open, is what Sinlaku will do in the final hours before its closest approach. Tropical cyclones have a well-documented tendency to behave differently than models predict in the final 12 hours before landfall. They can intensify more than expected in rapid pulses when the convective structure tightens. They can weaken briefly if an eyewall replacement cycle begins. a process in which the inner eyewall collapses and is replaced by a larger outer eyewall, temporarily reducing maximum winds but expanding the overall wind field. They can jog 15 to 20 miles off their forecast track in the final hours, driven by internal asymmetries in the storm's structure that no large-scale model can fully resolve. The jtwc forecast confidence for intensity in the 0 to 72-hour window is assessed as medium, not high, medium, which means the 145 mile per hour peak forecast is the most likely outcome given current information, but both higher and lower intensities are within the plausible range of outcomes. And the track confidence for the same window is also medium, with a cross-track uncertainty envelope that still spans more than 130 kilometers in the 72-hour forecast. Within that envelope sit the runways of Andersen Air Force Base, the harbor at Opera, the coral cliffs of Rota, and the living rooms of 153,000 American citizens who went to sleep Saturday night in condition of readiness 3. What the data actually shows, all of it, from the jtwc official forecast to the HAFS model solutions to the cloud top temperature readings to the sea state observations to the ground reports from Chuuk, is a storm performing exactly as a storm performs when every environmental parameter supports maximum intensification. This is not a case where the models are overstating the threat. This is a case where the models are tracking a real, physically coherent, observed system that is doing what the thermodynamics of warm ocean and low shear dictate it should do. There is no surprise here to the meteorologists watching it. The surprise will belong to anyone who did not prepare. On an island that has been told since Thursday that a Category 4 typhoon was the central scenario, who waited to see if it would weaken or recurve or somehow find a way to spare them. Some storms do weaken. Some storms do recurve earlier than forecast. But Sinlaku, as of this morning, has done neither. It has intensified on schedule. It has tracked on the forecast consensus. It has behaved like a textbook example of rapid intensification in a supportive environment. The question is not whether. The question is exactly how close and exactly how strong when the closest point of approach arrives Monday evening. 37 years since a storm of this intensity touched this part of the Pacific in April. 3 years since Typhoon Mawar showed Guam what Category 4 force does to an island in a single night. 18 miles between Rota and the forecast eyewall. 22 miles between the eyewall and the northern end of Andersen Air Force Base. 15 to 20 inches of rain on the way. 145 mile per hour sustained winds. A slow forward speed that means everything the storm carries will be delivered at length, not in a single blow, but in a sustained assault that lasts from Monday midday through Wednesday. The shelters are opening this morning. The windows are being boarded. The boats have been secured or moved. The emergency management system of Guam and the Commonwealth of the Northern Mariana Islands, tested by Pongsona in 2002 and Mawar in 2023 and U2 in 2018, is doing what it has learned over decades of living in the crosshairs of the most powerful storm basin on Earth to do. The people are doing what people do in these hours, making the calculations of what they can protect, what they must leave, where they will shelter, and how long they will need to endure before the other side of this storm arrives and the slow work of counting what remains can begin. The atmosphere does not negotiate. It does not issue warnings in advance. It issues data. And the data, right now, on the morning of April 12, 2026, is unambiguous. A major typhoon, already at Category 2 equivalent strength and intensifying, is 535 miles southeast of Naval Base Guam, moving northwest at 5 miles per hour, tracking toward a closest point of approach that the Joint Typhoon Warning Center places within 22 miles of Andersen Air Force Base at Category 4 intensity. The cloud tops are at minus 97 degrees Celsius. The sea state beneath the storm is 9.1 meters in building. The wind field is expansive. The ocean is warm. The shear is low. The models have converged. The forecaster called it alarming. The emergency declarations have been signed. And the hours between now and Monday evening are the last hours in which preparation is possible, in which movement is safe, in which a decision made today is still a decision made in time. After that, the wind decides. What remains when a Category 4 typhoon passes 22 miles from your runway, or 18 miles from your island, or directly over your village, is not a question answered by a forecast model or a probability cone. It is answered by the storm itself, in the darkness of Monday night, in the sound that fills every structure and every human ear simultaneously, in the water rising through storm drains and under door frames, in the trees that do not survive, in the buildings that do and the ones that do not, and in the silence that arrives sometime Tuesday when the eye or the post-eyewall conditions allow a first breath and a first look at what remains. Sinlaku is still 535 miles away. Every mile it closes, the margin between forecast and reality shrinks. And somewhere in the western Pacific, below a column of air reaching to the stratosphere, above an ocean that has been warm since before this season was supposed to start, a typhoon is tightening its spiral and moving northwest, 5 miles per hour, into the 36 hours that will define April 2026 in the Mariana Islands for the rest of this generation's memory.